Arthur Eddington, a pioneer in astrophysics. Who is Arthur Eddington? Here is a brief introduction.
An English physicist and mathematician, Arthur Stanley Eddington was a keen astronomer who devoted much of his life to explore the mysteries of our universe in the field of astrophysics. In 1882, he was born in Westmoreland, England, where he was raised by his Quaker parents Arthur Henry Eddington and Sarah Ann Choate. He later attended Bremen School, where he received a scholarship to the University of Manchester in 1898. Graduating with first-class honors in physics in 1902, he received a scholarship to the Trinity College of the University of Cambridge, where he obtained a master's degree in 1905. After 7 years, in 1913, he became Diplom Professor of Astronomy at Cambridge University and the Director of the Cambridge Observatory a year later. He taught astronomy for 30 years at Cambridge and focused deeply on research, winning the Smith Prize in 1907 and the Gold Medal in the Royal Astronomical Society and the Bruce Medal in 1924. He remained unmarried and died in 1944 due to cancer in Cambridge.
Over the course of his life, Arthur Eddington made profound theories and discoveries. Here are some of the most notable ones.
Eddington was most known for his contributions to astrophysics, most notably on his research and theories about the properties of stars. As of 1916 to 1926, Eddington was focused on extending the models of the structure of stars and stellar processes. From the model and results, he discovered the presence of radiation pressure to prevent stars from collapsing from gravity, and nuclear fusion from hydrogen to helium. Other properties for stars, such as the mass-luminosity relationship, the limit of the luminosity of a star, as well as their behavior in the center as being close to an ideal gas, were also discovered. He also widely advocated for Einstein's general theory of relativity and soon confirmed it in 1919 from observing light in a solar eclipse. Later on in his life, he tried to form a fundamental theory of the universe combining relativity, quantum theory, and gravitation, though he died before completing it.
Within the fundamental theory, he devised a proof for the total number of protons and electrons in the observable universe, by assuming the universe should be aesthetically and numerologically pleasing, and showed this number to be 1.57 times 10 to the power 79. This number is now known as Eddington's number. Physics in the nuclear fusion of stars. Stellar nucleosynthesis.
One major aspect of Eddington's research is his theories of stellar nucleosynthesis, proving that the source of energy that powers stars must include some atomic energy from nuclear fusion. In the 1920s, physicists had tried to explain how stars, for very long periods of time, could generate substantial quantities of energy for the levels of heat and light observed today. Prior to Eddington's work, physicists Kelvin and Helmholtz theorized how stars were powered by gravitational contraction. This theory argues how gravity acts on a star's outer layers and causes it to contract, which compresses gases inside the star. As a result, the temperature would increase and energy would be liberated in the form of heat and light. However, Eddington disproved this theory when stars, in order to expend energy as they are observed now, did not speed up rotating as much as expected, since contracting decreases rotational inertia while the angular momentum is conserved. Also, if the sun relied only on contraction for energy, it would be as large as Earth's orbit 25 million years ago, which is far below the time required for evolution and geological transformation on Earth. Eddington speculated that only mass being liberated into energy as of Einstein's equation E equals mc squared is capable of generating the immense levels of energy fueling stars. Using Francis Aston's research of helium atoms having 8% less mass than 4 hydrogen atoms needed to form helium through nuclear fusion, and assuming 5% of a star is hydrogen, Eddington was able to calculate the energy production of the sun. Eddington's results indicated that from nuclear fusion, the sun would be able to expend energy at the rate it is now for billions of years until it uses up the hydrogen. As such, the sun does not need to contract as quickly, so the sun should not consume Earth 25 million years ago, contrary to relying only on gravitational contraction for energy, and also agrees with Eddington's calculations of the speed of star rotation when using up energy.
From existing knowledge, Eddington calculated that the mass difference from nuclear fusion would be 0.03 daltons. He also knew that E equals mc squared, which using this formula calculated the nuclear fusion process from 4 hydrogen to 1 helium would release 4.48 times 10 to the power of negative 12 joules. Assuming 5% of the sun is hydrogen and calculating the hydrogen mass now, it can be calculated there would be 6.65 times 10 to the power of 43 joules of energy the sun can produce during its lifetime. time, as shown in the calculations on the slide. Using this information, if the current luminosity, which is the energy expended per second of the Sun, is as follows, the lifetime of the Sun is predicted to be 5.51 billion years from now. This was one of the most important discoveries and calculations of the time, for not only was it of significance to future human development, it also was fairly accurate in comparison with current findings using current technology and set the foundations of calculating subatomic energy from nuclear fusion. Eddington's work on nuclear fusion in stars, a relatively new field that required him to use advanced equipment, research complicated issues, and challenge current theories, reflects how Eddington's family, academic, and cultural background shaped Eddington's mindset behind and the outcome of his work, as follows.
The physicist, despite growing up in a small town with a family of limited income, relied on his academic abilities to obtain scholarships into the University of Manchester and later Trinity College in the University of Cambridge. This is a display of Eddington's motivation for academic success, which will be reflected in his work as an interest to test and form new ideas. Eddington spent a majority of his life studying or teaching in the University of Cambridge, which is a very prestigious institution with access to many quality resources such as equipment and faculty. He was also a fellow in the Royal Astronomical Society with many skilled astronomers to ask for help. These factors would have promoted the accuracy and reliability of his results, and allowed Eddington to feel more comfortable in conducting research in relatively new or advanced fields in astrophysics, like stellar structure or relativity. The university, and in England as a whole, also has a strong research culture, encouraging students to question current theories or ideas. This might have influenced Eddington to attempt to challenge the notion of gravitational contraction as before, which would have led into his research findings of nuclear fusion later on.
These strong backgrounds of Eddington's life allowed his work and theories to gain recognition and momentum in the scientific community. Though he contributed mostly to the betterment of our world socially, economically, and environmentally, he brought about negative changes as well.
Eddington's contributions brought about major positive changes in the field of astrophysics around the world. His most notable works are two books that outlined his findings and observations on the structure of the universe and stars, as well as an incomplete fundamental theory of the universe that shed light on incorporating quantum mechanics with relativity later on.
He also proved Einstein's theory of general relativity through observing a solar eclipse, and played a key role in promoting this theory to its recognition and relevance it has today, especially to the English-speaking world.
Eddington's work put forward important theories and concepts about astrophysics, which not only furthered the scientific world's knowledge of how the universe works, but also formed key foundations for future discoveries.
For example, it was speculated that without Eddington, many would still not realize the importance of Einstein's views, and as a result, technology beneficial to the livelihoods of our society that are based on relativity, such as GPS or space radars, would have been developed far later.
A key modern breakthrough from his research is nuclear energy, for Eddington not only suggested the existence of subatomic energy, but also envisioned the applicability of this form of energy in our world. Though current nuclear energy relies on nuclear fission rather than fusion in stars, a prominent pioneer in nuclear energy, Freeman Dyson, saw Eddington's work as a fundamental step towards our current nuclear technology, for Eddington was one of the first to realize its importance and actively promoted it to the scientific community, spurring quality discussions and progress. For example, during a World Power Conference of 1930, Eddington predicted that subatomic energy would provide a plain diet for engines previously pampered with coal or oil. Such technology has substantial benefits to our world. Environmentally, it does not generate polluting emissions nor use up precious fossil fuel reserves. Economically, this form of energy generation is reliable, efficient, and relatively not costly, which would in turn promote economic growth. These aspects resolve the urgent energy demands from the world population that is rapidly growing in size, leading to a better society of improved livelihoods where energy is more accessible and less costly. However, Eddington's research into stellar nuclear fusion also has shed light on harnessing nuclear technology for weapons, notably in the form of hydrogen bombs, where the high temperature and pressure from nuclear fission would ignite nuclear fusion. The energy released from nuclear fusion would cause a fireball much more destructive than traditional nuclear bombs, and while such bombs have not been deployed yet, they incite fears in the society of the environmental and social damage caused by a potential nuclear war. Development of these technologies are also a major burden on the country's economy, as they are intensive of financial resources better used elsewhere.
Despite his extensive impacts on the world, both good and bad, his work is sometimes misattributed to someone else, being omitted or not mentioned much.
In the field of nuclear physics, the theories of nuclear fusion as the energy source for stars rather than gravitational contraction were first proposed by Eddington in 1926. However, the credit of this theory is often attributed to a German-American physicist called Hans Bethe, who calculated the proton-proton chain reactions within the nuclear fusion of stars. Though Bethe's theories made important progress on Eddington's theories, some journals, particularly in America and India, did not mention Eddington's contributions to being the first to point out the possibility of nuclear fusion as energy for stars. For example, an article of Lorentz plasma physics in the US attributed the work of nuclear fusion to 1930s scientists, particularly Hans Bethe, which omits Eddington despite him playing a significant role in nuclear fusion research comparable to Bethe. This lack of recognition is likely due to the Eddington-Chandrasekhar confrontation when Eddington was reluctant to accept Chandrasekhar's theory, later proven true, of not all stars turning into white dwarfs, which once again Eddington's theory that all stars did. How Eddington openly ridiculed Chandrasekhar, an American-Indian physicist, caused controversy and portrayed Eddington to both American and Indians as racist, cruel, and arrogant. These caused Eddington's reputation to diminish and his work to be less openly recognized in the scientific community.
This incident made Eddington be seen in a negative light. For example, he was accused by an Indian newspaper as a homosexual soon after the incident. In contrast, Hans Bethe recognized Chandrasekhar as one of the greatest physicists of all time. As a result, journals or physicists tend to mention Eddington less and Bethe more due to their differing reputations. Those offended by Eddington would likely omit his name for Bethe, for how Bethe demonstrated a similar nuclear fusion concept while having a more positive reputation than Eddington. All in all, despite not being recognized for her work often, Eddington made significant contributions to the scientific community. Thank you for watching.